Dylan, thanks so much for being on the podcast.
Yeah, absolutely, Jared. Glad to be here.
I don't think people fully realize how we met, and it's kind of funny, and I kind of want to share it real quick. But I put up a post about Solstice, and I tagged the lingerie Solstice, and you put up a really funny post after, and then we hopped on a call, and here we are.
Yeah, I mean, so we're a 100% woman-owned small business, and at the time, I was the only male employee. I thought it was kind of funny that we got tagged with a lingerie company, and you know, if you can't laugh, then what are you doing it for? So
Yeah, it was your post was awesome, and I wanted to meet you even more after the post you put up about it because there's two types of people in this world, right? There's the ones like you that like made it an opportunity to actually put a post out of it and like laugh about it. And then there's the people that would be genuinely pissed for no reason, even though it probably got them more attention. Yeah, anyway.
yeah, right. I mean, that's a whole different market segment than we typically target. We had not looked into the couture lingerie market for nuclear power.
One day. I'm really excited to have you here. We had a really good call a while back, several months back now. When you and I talked, I was in Boston because I was getting away from the hurricane at the time in Florida. For our audience, I would love for you to quickly share, your role today and what Solstice is all about. And then we're going to talk a little bit about new nuclear, the case for small modular reactors in certain cases, and then really a new way of delivering nuclear. But let's start with your intro.
Sure. So my name's Dillon Allen again, and my background has been in primarily the nuclear industry, but also in the broader utility industry over the last 25 years. Started out doing submarine and aircraft carrier design, and living in DC. Had the opportunity to come home to Mississippi, where I worked for the utility here. The nuclear organization is headquartered here in Jackson, Mississippi, literally 10 miles from where I grew up. It was a great opportunity to come home. We were looking at building new nuclear plants back then in '08. As the economics fell away from that energy source, that project died, and I did other large capital projects across the utility. Last year, I was helping build up what was going to be the advanced nuclear program for the company, and I had the opportunity to step away to Solstice and to help not just to help the entire industry move forward with a little bit broader view. And yeah, so now I'm helping our CEO Brooke Morrison run Solstice. We're doing primarily consulting work, but we're also looking into ways that we can help clients, actually go deliver the projects that they're wanting for their energy source. And it's really exciting. We're bringing a lot of seasoned folks from the industry, via our networks have reached out and have wanted to join us, and it's just been an absolute blast. We bring in former, CNO, chief nuclear officers, former CFOs and CEOs, and senior leaders across the industry who have built them, who have designed them, who have operated and maintained them, who regulated them. Got a couple former NRC, former public service commissioners on the team. It's just been a really awesome experience to get to help the industry, the folks that we know, that we've worked with over the years, to get to go help them, bring a team like that as a consultant.
It's really an exciting time because I feel like we've talked about nuclear for years. It's not a new conversation, right? But I feel like it was like the conversations were re-energized towards the back half of last year, especially with um, just how much AI has like the conversation around AI and data centers and the need to power these data. Now, there's obviously way more use cases than that, but it seems like AI helped nuclear get so much attention the last 6 months.
Yeah,
Yeah.
the conversation has really shifted. When I started working on advanced nuclear in my past job, it was an annoyance to my boss. Why are you working on this? We're never going to do this. And the conversation shifted to how do we might do this, and then it shifted to how do we do this, and it seems to be shifting to what are you waiting for? And there's multiple drivers. One, there's areas of the country that are somewhat constrained with their natural gas infrastructure. which provides perfectly good electricity, right? Natural gas works great. It's a very highly efficient process to go build a combined cycle gas turbine where you have a couple jet engines basically making electricity, and then the heat from those jet engines is making steam and turning a steam turbine that works just like a nuclear turbine. It's a great way to use the energy, and we have an abundant resource here, but you pull it out of the ground, you got to move it somewhere. So, like in New England, for example, in the winter, the people using the natural gas at their house get precedence over the gas-fired power plant. And so if you build only gas, then eventually you hit a point where when the solar panels aren't working and when the wind isn't blowing, there's not enough gas supply. And eventually you get to a place where you may have rolling blackouts, in the winter when you need your heater running. Or similarly, on a very hot day, gas is not nearly as big a challenge in the summer because people aren't using it for heating. But the point is, nuclear provides a diverse fuel source, and I believe the long-term economics are actually better. When you're making the decision for how something goes onto the grid, you're looking at basically a net present value, an NPV of various resources, and saying, oh yeah, well, this one makes sense. I don't know that the modeling really exists yet for the full grid picture of what the full impacts are. I think that may be a whole solar and wind pencil out right now economically, but they're pretty heavily subsidized. Plus, they can sell renewable energy credits, so they get credit for making the power when they can make it, and then also for being green, selling it, so that somebody that's using their lights at midnight can take credit for that solar energy that happened earlier in the day, even though those electrons are likely coming from a nuclear plant or a gas plant or a coal plant. So point is, there's a big driver there. Yeah, there's a big driver to provide some fuel diversity, um, and I do think the economics are trending in favorably now. And again, it's on paper. Admittedly, it's on paper because we haven't built any of these advanced reactors that we're going to be talking about a little bit later.
I'd say though the two like the one of the interesting opportunities with nuclear is also in the setup of it. Like solar panels, putting like solar panels, like if you were in New York City or something on every single building. I know we're starting to build like better solar panels, right? The ones that actually will be like built into the roof, so it's not these giant ugly solar panels that you're putting on everyone's roof.
Or the windows, in Denmark, they're pretty far north, and up in Scandinavia, they have like they're vertically mounted because the sun is way down to the side. So vertical, there's all kinds of really cool stuff coming in the market with solar. The challenge is the sun shines when we're not using the power primarily. I mean, usually so the shape of the power necessary on the grid at every moment that people are using power, the amount of power being put into the grid has to equal the amount going out, and you have to balance the voltage, the frequency, the volts, amps, reactive VAR. Think of it like the suds on the beer. You don't get anything for it, but it's filling up your glass. So you have to balance all of those things, and you need to be putting in as much when you're using it. And the way it works is usually the mornings and the evenings, and it depends on the season and where you are. Like, why are you using that energy? Are you turning on air conditioning in the summer in the Gulf South of the U.S. or down in Florida? Like, you turn it on the AC to keep it less than 95 in your house, or are you heating? Are you powering some industrial load that runs around the clock? And so that shape of the curve is very different than the shape of the curve of solar. And so that's where battery or some other storage comes in, but utility scale battery storage, to get to the level of storage that you get out of like 1 hour of just a small modular reactor, a 300 megawatt small modular reactor, you need 300 megawatt hours of battery storage to power the grid for 1 hour, or the same amount of grid power for 1 hour. Well, there's, my local utility doesn't have that kind of battery storage on the system across 4 states, right? So they have near like a tenth of that, and so you'd have to have 10 more times the battery that they have right now just to power what you can power with one SMR for 1 hour. And so to get all the way through the night, you'd need that times 10 or 12. And plus, you'd have to build a whole lot more solar panels and wind because you can't just have the same amount of power as you need to get through the night. You got to have enough to get you through the day and power up the batteries to get you through the night. And so when you really do the math on that, you've got to build out a lot more megawatts to get you to the same real physical position, because as it turns out in electricity, physics, matter.
I read something recently about, in the future, when we start looking at these futuristic cities, right? Like, I personally thought we would have been more further along with futuristic cities at this point. Whenever you look back at the old movies, right, in
Where's my
2020,
hoverboard?
yeah, where's my hoverboard? Exactly.
Right.
I'll even settle for something less than, like, I'm totally fine with not having a flying car. I mean, people can't drive on the ground. In the air is probably not going to be much better, right? A big part of these futuristic cities will be having like the small modular reactor in these cities, and it's not like you can put a giant wind farm in a city. It has to be like way far out. So,
Right. Way out, right? Like way out, either in the ocean or on land. And there is some. I was driving with my window down the other day, and every time I passed a car, I heard, "Oomph, oomph." And so that there's some potential sonic issues with the as those big blades pass the tower, how you get a whoop, whoop. And there are some people looking at whether or not that's impacting marine life, especially marine mammals who are pretty sensitive to sound and use it to
oh, I did
communicate.
not even think about that.
Yeah, I haven't even I haven't read a paper. I don't know if there is a paper, but I've seen some articles on it. So that it's like we don't know what we don't know yet because we haven't been putting massive wind development. But the point is, you're right. You're using thousands of acres of land and having to tie all those things together with a lot of wire for something that you could use 25 acres and be compact, have a one place that people can go. We know how to maintain the things well. They can keep operating during a hurricane. If you can choose whether or not to operate them in a hurricane, and it depends on really if you need grid power coming in, like our current operating fleet. A lot of times you may make the decision, hey, look, we're going to shut down as the hurricane comes through to make sure our offsite power can keep coming onto the plant to power the loads we need to cool the core. But the more advanced designs are they don't need offsite power, a lot of them. And so if you don't need offsite power, then you can just keep trucking through a hurricane, through whatever, and never stop providing the electricity unless the load goes away. And you may have to drop off the grid if too much load goes away because of an event. But
I will just share though, solar, like nuclear, was given a bad, like there was a lot of bad PR about it for so long. Like, the worst thing you said about solar is it's ugly. The wind farms, it was like even they're just these big, but solar, it felt like for so long there was a negative around it, but it wasn't like a fully justified negative. So when did things start to shift back to having positive conversations about nuclear energy?
I mean, I would say over the last 5 years, so there was a heavy push from the decarbonization and climate angle, which is a great reason to I say nuclear fulfills my inner hippie because I want to use fewer natural resources to get the result that we need as a society, and nuclear hands down does that, which is why I believe in the technology. Solar is a great thing for certain applications, but what we found when you go look at a place like California, and what you find is you build out all of this solar to replace a utility, a grid scale, utility deployment of electricity, and it doesn't fulfill the same function. It is great to provide power. If you're out remote, I got a lot of friends that live kind of off grid or very near off grid. In that application, hey, it's amazing. Like, it provides power. You're choosing to live in a way where you're not using power on the same curve, and you can put in a battery bank and build enough to power your house. Like, so it kind of works on that scale. But when you start looking at a grid where you have large industrial loads that are operating 24/7, it doesn't pencil out the same. And I think as solar and wind began to increase their penetration into the grid scale, as you start to see some of those real engineering limits to what the technology can do, I mean, you can fix it with enough money and space to put the batteries or some thermal storage or some other way to keep the energy that you made when the wind was blowing or when the sun was shining. You can fix it, but it may be really expensive and it may take a ton of space. There wasn't anything driving that conversation until you started seeing some of the effects. Like it's called the duck curve in California, where you don't even get to retire the assets that you thought you were going to retire. They're spinning a turbine because the solar comes on in the evening or in the morning, and then in the afternoon it kind of drops off pretty suddenly. And so all these spinning turbine plants, dispatchable plants, gas plants, coal and nuclear to some extent, although a nuclear plant can't respond like this. They have to ramp up really fast, and that's hard on the equipment. It's less efficient, and you didn't get the people that work there are still working there, right? So you're not saving any money on the people. You're not saving any money on the maintenance of the plant. You just spent a lot of money on something that sounds great, but it may not be great in that particular application.
So talk me through, I want to shift focus a little bit. Talk me through some of the cases for these small modular reactors. Like, what are some very logical use cases that hopefully we can implement as soon
Sure.
as
Yeah.
possible?
And so there's the only thing we've really used nuclear power for. Okay. Well, the first non-violent use of nuclear power was pushing a submarine, right? And so we used it to make electricity and to provide a motive force to do something. But basically, it just spun two turbines. It spun an electric turbine and it spun a steam turbine to a propulsion turbine that was attached to a propeller, whirligig, make the submarine go. Every civilian use has just been really you provide electricity. And there's a 3 or 4 companies that are out there that basically built out the entire U.S. fleet, and a few more that are out globally. And it's a light water reactor. It's basically the same technology used in a submarine with some different configurations of things, but same idea. You heat the water, you make steam, you spin a turbine, you send it back, and whether you do that in one loop boiling water reactor or 2 loops in a pressurized water reactor, it's all the same process. And there's those what we'd call Gen 3 plus. There's some reactors out there that are being developed. People like GE, Vernova, Westinghouse, Holtec, NuScale. They're building light water reactors that are really well designed to go do that mission, right? Like go spin a turbine. They're just advanced designs that have built on all the history that we have across the operating fleet. And then there's this other class of reactors, I think Generation 4 is what they're typically called. And they use all kinds of different coolants than water and different configurations. And we can have another episode about and go super nuclear nerd. But the point is, a lot of those are really good at providing very high temperature heat, which solves a lot of industrial problems. In most industrial facilities, there in most industrial facilities that are processing chemicals or changing things from one to the other, there will be heating necessary to get processes to the right temperature. And so a lot of these Generation 4 reactors, they may not even put an electric turbine on them, because the end use is the heat directly, and it'll be way more efficient just to make the heat rather than to make the heat, turn it into electricity. You lose a little bit, and then take that electricity and turn it into heat again. The light water reactors may have some of that in their capability. I know some of the developers out there are looking at, can you provide the heat with a light water reactor? But these new reactors are really being designed for it. It's opening up a whole new set of customers, because previously the customer was the grid, and now the customer may be a refinery or chemical plant that's processing, turning some feed chemicals into some output chemical, like the plastic to go on the case of this foam, or whatever the case may be, making paint, making whatever. Everything you look around, 90% of it came out of a chemical plant as a feedstock somewhere, right? So use that whole new use case is just totally, that's another thing that, kind of going back to our why are we talking about it, was because the machines can do something, or will be able to do something. They haven't been built yet. They can do something that hasn't been done before in a market that hadn't been used.
And do you envision, like, obviously with any major technology, things have continued to get smaller and smaller and smaller. Like, I'm assuming nuclear will be no different in that. I mean, it's already happening with the small modular reactors, right?
Well, and it's an interesting thing because, for the zeitgeist of the industry was that, oh, the bigger you are, the better off you are because you can generally operate a plant with about the same number of people. After you get the cost of building the plant into your net present value, kind of one of the next largest costs is the people. In fact, plants that are going to shut down a lot of times are like, well, but the jobs. And I would argue if you're making the jobs argument, then you've lost the economics argument somewhere else. But it's a valid thing, right? It does provide jobs in the economy, but maybe not highest and best use if you're really providing the most economic form of power. So the existing utility fleets are all looking to like make their operations as efficient as possible as we transition from kind of the first, second generation of nuclear workers into our generation of nuclear workers. No, there's just fewer of us because the 80s were not a good time for nuclear power. A lot of nuclear engineering programs shut down, and where the industry's staffing back up, but there's this kind of demographic cliff of folks that are nearing retirement, and then folks that are just young folks coming back into the industry. But where was I going? The idea was large is better, right? Get more megawatts per person that you're paying or building. You'll do better. And on the grid, that certainly may remain the case. The advanced designs are bringing a safety case that is better. In nuclear, basically nuclear safety, what you're trying to prevent is release of radioactivity in general, but specifically from the core. Like you don't want core damage to then result in release of radioactivity. The safety case of these advanced reactors is so much better that you don't require a lot of the same ancillary systems that you needed in the older designs, which means you don't need as many people to operate them. As you drive out all of the stuff that we added onto the designs of these large reactors, you get rid of a cost drive. You get rid of people, so that the staffing is better and significantly better in some cases. On a per megawatt basis, the staffing's better. And so now if you can get the capital cost, you're challenged. If you go dig a hole and you go pour a lot of concrete, there's some kind of base level of infrastructure that you're going to have to go invest there. Spreading that across fewer megawatts, that hurts the dollars per megawatt that you're paying to the dollars per kilowatt is how it's usually talked about. The challenge is the economics there. As the designs become more modular and easier to construct, so that you can build them mostly in a shop somewhere, don't have to worry about the weather. You ship pieces to the site, lay it into the room that it's going to be in, pipe it up and keep trucking. So you eliminate construction risk. You do all kinds of things to bring that construction cost down, and the economics start to get to a place where you can be competitive. Now again, that's on the grid, but what if you're trying to power something that requires like 100% or 99.999% reliability? It's some a tier 1 data center that is absolutely critical data that needs to be running whenever it needs the power. Well, if you put a gigawatt power plant on that data center and it drops offline, and nuclear plants are not the only plants that drop offline. Other things happen in power plants. Sometimes things break, and you shut it down so that you can go fix the thing that broke. It's part of large equipment. But if you put a gigawatt plant on that gigawatt data center, and you lose that whole plant all at once. Now you've got to suck in a gigawatt from the grid and some other plants have to turn on and respond very quickly, and it's a pretty large impact. If you instead power it with 4, 300 megawatt reactors or 12 80 megawatt reactors, using numbers based on some of the designs that are out there. So like the GE, Westinghouse, Holtec, they're all about 300, and then a lot of the Gen 4 stuff they're in that 60 80 megawatt range. But so if you put 1,000 megawatts on the grid with 4 units or 12 units, then if you lose one of those units due to an equipment failure, it's a lot easier to back up that power with grid power or with the diesel or with a battery for a minute. Whatever the case may be, it becomes much easier to provide that super high reliability that's necessary. So the reason you power a nuclear ship in the Navy is not because it costs less, it's because it executes a mission that nothing else can execute. The mission for some customers is the reliability. That may outweigh, well, this is even a little more economic on paper. It's cheaper to build, a gas plant. Well, okay, right, but it's better to have 12 80 megawatt nuclear units so that if you lose one, you're okay.
Dylan, I want to thank you. Like, I definitely want to have you come back on. Like, I want you to teach a course on this. Honestly, like, I love how you explain everything. I really appreciate having you on the podcast. We'll definitely do this again soon. But thanks so much for joining us here today and for teaching, a lot of us more about, where nuclear is heading and also, just kind of really a mindset behind, what needs to happen as well.
Yeah, absolutely. And I appreciate I can go off topic. You're going to have to give me a much more
No, I
stringent
like it.
rule
I
this
just
time.
wanted to have you on and just to have you go. So you succeeded. Thanks so
Yeah,
much.
well, look, I'd love to come back. Great to talk to you, Jerry.